To use L'Hopital's rule to solve this problem, when we plug pi over 4 in place of the variable u, we should get 0 over 0 or infinity over infinity. So let's see if we can do this, where maybe we can just plug the number in and it will work. Let's see. That's tangent of pi over 4 minus cotangent of pi over 4, all divided by, and that's 2 times pi over 4 minus pi over 2. Now, tangent of pi over 4 is 1. Cotangent is the reciprocal of tangent, but 1 over 1 is equal to 1 over 1. Those actually have the same value. And in the denominator, well, 2 times pi over 4 is pi over 2, minus pi over 2. What do you know? When I look at this thing, the numerator is 0, the denominator is 0. So unfortunately, you can't just put this number in to solve for the value of the limit, but because we got a 0 over 0, an indeterminate form, we can actually use L'Hopital's rule. L'Hopital's rule say, well, since this didn't work, that's no good, I can take the derivative of the numerator and then the derivative of the denominator, and I'll figure out that limit instead. Okay, so trying this again, this is the limit as u approaches pi over 4. Okay, so the derivative of tangent with respect to u is going to be secant squared. And the derivative of cotangent, well, that's going to be negative cosecant squared of u. In the denominator, the derivative of 2 times u, we'll use the variable, so we just get 2, and then minus the derivative of pi over 2. Well, pi over 2 is a number, so its derivative is 0. And I think it would be helpful to maybe simplify this a little bit. So this is u approaches pi over 4. The denominator is just the number 2. And the numerator I'll write as secant squared of u. Then we'll get plus cosecant squared of u. So this thing. Well, I don't think L'Hopital's rule is going to apply anymore because, well, if you can't really even plug u into the denominator. So I think we can just plug pi over 4 in place of both of the u's and get a value for this limit. So let's see. The value of the limit should be secant squared of pi over 4 plus cosecant squared of pi over 4. And that whole thing is divided by 2. So to complete this problem, really what we need is the exact values of secant and cosecant at pi over 4. Well, I'll do that off to the side. Well, secant is the reciprocal of cosine. So that'd be 1 over cosine. And cosine of pi over 4 is root 2 over 2. Which, if you are dividing by a fraction, you'll multiply by its reciprocal. So this is equal to 2 over root 2. And probably expressing this so it doesn't have a root in the denominator would be a good idea. So I'm going to multiply the top and bottom by root 2 over 2. Both by root 2. And we get 2 root 2 over 2. The 2's cancel, and we're just left with root 2. So, long way to go, but secant of pi over 4 was the reciprocal of cosine. I knew the exact value for cosine, so I plugged it in, did a little bit of work to simplify it, and it's equal to root 2. But we want secant squared. So if we square this value, squaring root 2 will give us exactly 2. So that's the value of secant squared. It's 2. Okay, so the next good thing is, well, cosecant, put that off to the side. If you look at cosecant of pi over 4, cosecant is the reciprocal of sine. But sine and cosine have the same value at pi over 4. And what this means is cosecant of pi over 4 is also equal to root 2. what happens is if you call this sine of pi over 4, it's also equal to root 2 over 2, meaning it'll simplify to the same number. And if we square cosecant, it means we square root 2, so this is equal to 2 as well. So here's the limit. This and this were both equal to 2, and we're still dividing by 2. This is 4 over 2, or simply 2. So that is the final answer for this problem.